I will discuss the alien colonization threat in this video. So this is actually something much worse than an extinction event. People worry about some meteor or asteroid, something crashing into Earth and humanity gets wiped out, but I think it's even worse if humanity gets colonized. So Fermi asked this question, where is everybody? Why are the aliens not here? And the answer could be that they are on their way. Now, there are four very large numbers, okay? The time our universe has existed, about 14 billion years, number of stars and planets in our universe, the amount of time that has been available for travel between stars and galaxies, and the distance between galaxies. Now, we look at the first three numbers and we think, why haven't some aliens traveled to our solar system? And the point is that you can't really just look at the first three numbers, you also have to look at the fourth number. So once we have estimates of the travel times between stars and galaxies, then we can see how relevant the fourth number is and develop a better understanding of Fermi's paradox. So in the book, there are feasible designs for interstellar and intergalactic travel, along with what speed we can expect those spaceships to travel. So based on that, okay, first let's just look at how much time do we think that if some other alien species started out on space colonization, how much time they would have had. So the Big Bang was about 14 billion years ago, and then it didn't immediately create stars and planets, but first you had nucleosynthesis produced isotopes of hydrogen, lithium, and beryllium. And the first stars were formed about 0.1 billion years later. And so we need also the heavier elements like carbon, oxygen, nitrogen, calcium, iron, etc. For life, and these were formed by stellar nucleosynthesis. So there's two rounds. First, these were formed by stellar nucleosynthesis, and then that matter, for example, if it was a supernova and it ejected these heavier elements, and then later these heavier elements formed planets on which life arose. So if you look at Earth, our solar system was formed about 4.5 billion years ago, and our galaxy Milky Way was formed about 13.6 billion years ago. So taking all these numbers into account, we can say that about an alien species would probably have started its journey on space colonization about 8 billion years ago. No, they should not be human space colonization, they should rather be alien space colonization. So about 5.8 billion years after the Big Bang. Okay, so now you have an idea of how much time the alien species would have to start colonizing space. Now, we also from the book, we have a plausible number, something that can actually be achieved given our current knowledge of physics for intergalactic travel. And if you look at the observable universe, it has a radius of about 46.5 billion light years. So immediately you can see that, okay, an alien species couldn't have traveled this entire amount in 8 billion years. And of course, from the book, what you also realize is that we can't get anywhere close to the speed of light. And the volume of the observable universe is about 4.21 into 10 to the power 32 light years. A truly astronomical number. And based on the speed at which intergalactic colonizing flotilla can travel, we can estimate, and assuming all manner of isotropy, so I think like everything is like very uniformly distributed. Okay, all these alien species which are there in the universe, they're also just very uniformly distributed. There can actually be something like 229,000 space colonizing alien species which have been busy colonizing our universe for 8 billion years, and they would have only colonized about 52.36% of it in those 8 billion years, and the remaining 47.64% of our universe is still left to be colonized. And maybe we're just lucky. Our Milky Way happens to be in this remaining 47.64%. And so, yes, there can be alien species in the universe, but 8 billion years is just not sufficient time for them to have reached our Earth or our solar system. But there could be like something like over 200,000 species which are colonizing the universe, and they just haven't reached us yet. So as we speak, there could be a alien colonizing flotilla headed towards us. Just because we've not encountered any aliens till now does not mean that we will not encounter them in the future. And there is you look at the behavior of humans, and humans haven't solved this issue of just fighting with each other and destroying everything. And if that keeps happening, of course, humans are not going to be colonizing space. And that's an important issue which is covered in my books. So irrationality can actually overcome this evolutionary hardwiring, and if those species have overcome that hardwiring, then they would be colonizing space. So if an alien species arrived in our solar system, what can we expect? Well, firstly, of course, they would have much superior technology to our technologies. So and what sort of treatment can we expect from them? So they are more intelligent than us, they have more technology. Would they respect us? Would they treat us with consideration? Or would they treat the way we treat other species who are less intelligent than us and have less technology? Okay, so how do we treat other species? We boil lobsters alive. We cut the throats of cows and let them bleed to death. We have sharks, they cut off the fins and then they throw back the shark into the ocean to die. So we are pretty harsh with other species, and we will not really expect, we cannot expect better treatment than we mete out to other species. So President Carter on Voyager 1 said that it's our goodwill in this vast and awesome universe, lobsters, cows, sharks, and most terrestrial animals would vehemently disagree with human goodwill. It's okay. This is the worst outcome than an extinction event. So we should colonize our solar system for our security, because even though we would probably not have the same level of technology as an alien colonizing flotilla, but by sheer numbers we may succeed in defending ourselves. We should not indulge in wishful thinking, and these can be the different wishful thinking that, oh no, there's not going to be any alien colonizing flotilla because there are no intelligent species in the universe. No intelligent species are book similar. This one and its companions have solved the infirmities of war and demographic bust and have begun the process of colonizing space, which will result in their reaching our solar system in the future. That also could be wishful thinking. Maybe they have similar books. And finally, if you watch these movies, I think there was this movie, what was it, like Independence Day or something, which this alien flotilla came in and they were just like depicted as being horrible. They just wanted to kill humans and they just wanted to take over our resources, and therefore they were like bad. But we don't. That's what we also do, right? That's what we do to other species. We don't really have much of a moral standing to accuse anybody else of being evil, right? And neither should we expect that another alien, if a colonizing flotilla turned up, that they would not treat us as a resource and would treat us as their equals. Of course, in that movie, everything ended up well. The humans came up on top, but that's of course a movie. You don't want to. You want to be more thoughtful than happy endings that you get in movies. Okay, so if an alien colonizing species targeted our solar system and they found that it was already very populated with 54,000 trillion humans, they may decide it's not a good target. They may say that just by the sheer numbers, they should not try to colonize. Because of the sheer numbers, they should not try to colonize our solar system. And how would they know what is our state of technological development? Now, there was this interstellar object, Oumuamua, which came in 2017. And if it was a probe, why would a flotilla send out a probe? Because they don't want to land up in the solar system having exhausted their fuel and find that that solar system already has a species which can resist the colonization. They would rather head towards a solar system which is not colonized or is not at a level of technology which it can defend itself. So that's why you would want to send a probe. And how would the probe work? Well, the probe could record radio signals. And what they would find is that a huge amount of radio signals were being transmitted from Earth, but nothing else in the rest of our solar system, or very tiny ones like, some Mars orbiter or something like that. So that would give the probe and the approximate idea of the state of technological development of the transmitting species and the size of its population. And unfortunately, the conclusion colonizing flotilla would have, and if they got this information, was that they would not meet any significant resistance if they wanted to colonize our solar system. Now, was Oumuamua an alien probe? Now, there isn't that any evidence that was a probe constructed by an alien species, but there were some features. It had like 6 features which seem to be at odds with a natural origin. So why did this thing turn up interstellar object, and possibly some things which cannot be explained as a random product of nature? So how should we think about this? Should we say that, okay, we don't have enough evidence that there are alien colonizing flotillas? Or should we say that the threat is so great that if that happened, that we should not be looking for to get evidence for confirmation that they do exist? So in the sciences, we consider alternative hypotheses and accept and reject them based on evidence. The null hypothesis is given the benefit of doubt and is assumed to be true unless there is compelling evidence against it. Okay, so that's how you do your test your hypothesis in science. Now, the question arises whether the null hypothesis should be that a colonizing flotilla is headed towards Earth, or whether the hypothesis would be that no such alien colonizing flotilla exists. And if you take the null hypothesis to be no such alien colonizing flotilla exists, then there is really not enough evidence to reject this null hypothesis. And then we should, like, our hypothesis should be that no such flotilla exists. However, if the null hypothesis is that such a flotilla is heading towards Earth, then there is not enough evidence to reject that either. The thing that you can sort of Oumuamua was not it's definitely not conclusive. It's just mildly suggestive. Okay, so what should be the hypothesis? What should be the null hypothesis? And that comes down to the relative cost of making a type 1 or a type 2 error. Okay. Now, wrongly rejecting the null hypothesis that an alien species is headed towards Earth will likely make humanity's future much worse than mass extinction. Now we'll end up like being treated like we treat cows. We'll be locked up in pens and like, I don't know, it's a horrible thought. On the other hand, if you accept the hypothesis that an alien species is headed towards Earth, and that is really not true, then what is the cost of that? Nothing. I mean, there's practically no cost of it, because if we go out and build these space habitations and we have 54,000 trillion humans in our solar system leading lives of luxury and happy lives, that's not costly, but that would also provide us a defense against any colonizing flotilla. So the null hypothesis that there is an alien colonizing flotilla headed towards Earth should be accepted as true unless there is compelling evidence to believe otherwise. There is no compelling evidence to believe otherwise. So, okay, what are the arguments in favor of the null? Assuming that the null is that there is such spacefaring alien colonizing species, the arguments would be that we don't see any evidence against this null because the universe is still relatively young. 8 billion years is not a whole lot of time when you look at plausible velocities for intergalactic colonizing flotillas, which those numbers are worked out in the book. That's one. The second one is that there are simply a massive number of stars in the universe and possibly a similar order of planets. So that would lead us to think that yes, there could be intelligent species on other planets too. And life on Earth appeared very quickly after the Earth was formed. So though the molecules of life are complex, it doesn't take very long compared to the age of the universe for them to form. I should also note that there's something called the Cambrian explosion, and the Cambrian explosion has basically happened I think about 600 million years ago, 500 to 600 million years ago, and that's when the more complex organisms appeared in all this. So maybe yes, life did appear about over 4 billion years ago, but for a long time it took a very long time for more complex life to appear. Now, and finally, another point in favor of the null is that this book has a plan for human space colonization that is feasible according to the laws of physics. Intelligent life elsewhere may devise a similar plan. So it's not really technological or the issues. The important issues are psychological and social rather than physical. Now, these were the arguments for the null, that there could be colonizing flotilla headed our way, and the arguments against would be, well, we haven't encountered any aliens in our thousands of years of recorded history. A rare Earth hypothesis says that the conditions necessary for life to originate make it a very improbable event. And even though if life did originate, intelligent life capable of interstellar and intergalactic travel is unlikely to develop. Can't say that these arguments are compelling. And when should we expect to see them? I don't know. Could be tomorrow, in a year, or a billion years. We don't know. We don't know what is out there, and so we should. Because we don't know does not mean that we should dismiss it. So if we have, let's say, 1 million space habitations, which has 50 billion humans, we should be able to protect ourselves. And according to estimates in the book, we could get to 1 million space habitations in about 1,000 years from now. So let's hope that nothing appears in that 1,000 years. Okay. And there are details in the book.